Welcome everybody. My name is Kim. I am a community learning specialist with NewSpace, and welcome to Littles Lab. Littles Lab is our program for 3 to 5 year olds, where every week we do something fun and new based off of a different theme every month. And this month's theme is let's do experiments. And so my first question for you is, what is that? What is an experiment? That might be a brand new word for you. What is an experiment? Well, let me tell you something. You do experiments every day. You are doing experiments all day, every day, especially at your age. If you're like, and growing up, everybody does kind of experiments in one way or the other. Basically, an experiment is when you try something new or test something to see what happens. Have you ever done that before? Have you ever maybe, even just like touching something to see how it feels? That's an experiment to learn something new. If you've ever done an experiment of what happens, like if you've built blocks up taller and taller and taller and taller, and then you touch it, what happens to those blocks? I bet you've done that before. Do they topple over? Yeah. So if you've ever done that, you've done an experiment. If you've ever just trying out something, if you've ever wondered, what happens if I do this? What will happen if I do this? That's an experiment. And you're probably doing that every day. You might not be consciously thinking like, what happens if I do this? But you might be. Or if you've just thought like, I don't know what's going to happen. I don't know what happens when I do something, and I want to learn what happens. Then you're doing an experiment. People are kind of doing experiments every day. So that's what we're going to be talking about this month is we're going to be doing different experiments with different things. So in the past couple months, I've been showing you different apps that kind of go with our theme. Well, there's not a lot of apps that help us learn and kind of do what experiments. Experiments are more of a hands-on thing. So today we're going to do a story, but instead of doing an app, I'm going to show you, we are going to be playing with magnets. So I have all sorts of different kind of magnets here, and we are going to be talking about those. And I bet you may have played with magnets before. Where do you think you've ever seen a magnet before? What do you think? I'll give you a hint. I bet there are some in your kitchen right now. Where do you think you might see a magnet? Do you think you might see a magnet on your refrigerator? Yeah. A lot of times there are refrigerator magnets. If you have things that are holding up pictures or pieces of paper or things like that, or just sticking to if you've ever seen something just stick onto your refrigerator, those are being most likely stuck on there with magnets. And so we're going to talk about a little bit about how magnets work, and we're going to be doing some experiments to see what will be attracted to a magnet or stick to a magnet. Kind of like this. Ooh, this guy sticks. How does that work? Why is this little thing sticking to this magnet, right? We're going to kind of talk about that. We're going to be doing some experiments with that. So if you have done any experiments, let me know in the chat, or let me know if you're watching this on YouTube, let me know in the description below. What are some experiments you've done? What are some things that you like to do? If you've ever wondered, what happens if I do this? And then what was the result? What happened? Let me know. So we are going to get started by looking at our calendar today. So I really like our calendar because it helps us with our days of the week. It helps us with our numbers. It can even help us with our letters, and just in general helping us with our month, which I really like. It's always good to know and learn those type of things, right? So let's take a look at our calendar. I'm going to share my screen with you. And perfect. Okay. So you should be able to see my screen Now you should be able to see kind of like a dark background with a big white triangle in the middle. So yeah, so I'm gonna have you guys pretend with me. So usually if we were in our building at Do Space, I would have um, my friends come up. We have a really large touch screen computer screen, and I would invite friends to come up and touch them. And so I want you to pretend with me. Can you, when I tell you to and tell you what to touch, can you touch your screen? I want you to help me out because that will move our screen along and move our activity along. So for example, I would like you to touch the big white triangle right here in the middle. Can you touch that for me? Can give that a touch right now. Excellent. So you should see right now our month that we're in, and then this is the year that we're in. And my question for you is, what is the month that we're in? Or maybe let's start with this. Let's start with our very first letter of our month. So this is the very first letter of our month. And you probably, if you have been here for the last couple, if you were part of our month Lowe's Love last month, then you should know what this letter is because it is the same letter that started in our month of June. Do you know what our month is called? Or sorry, our letter is called? Is this letter our first letter in the month? Yeah, it is our letter J. That is our letter J. And then if maybe you also know what our month is called that starts with our letter J. And we have a lot of months that start with our letter J, right? Last month was June. We have one at the very beginning of the year called January. We are in the month of July. July. That is right. We are in July. So that is what our month is called. And then this big number is our year. So we are in 2020. So 2020 is 2020. It's a pretty big number, right? Okay, friends, go ahead. You should see a big green arrow in the bottom right-hand corner of your screen. Can you go ahead and touch that arrow for me? Oh, excellent. So yeah, so this is what our month of July looks like. Our month of July, you can see where it says July here and then 2020 here. And then right at the top, we have our 7 days of the week. And it is so important to know our 7 days of the week, right? They help us because we go through our 7 days of the week every week, through every month, throughout our entire year, every year. So it is so important to know our 7 days of the week, right? Absolutely. So let's say our 7 days of the week together. So you say them who you're with, and I'm going to say them with you. So let's start with Sunday. So we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. That's right. And who knows what our day of the week is today? Do you know what our day of the week is today? It starts with our letter T. It's all goldy right here. It comes after Monday, but before Wednesday. Oh, I saw that our friend Daniel. Daniel, do you know what our day of the week is? Can you put it in the chat? I bet you do know. I bet you know what our day of the week is. Is our day of the week Tuesday? That is right. Today is Tuesday. Yep. So that is our day of the week. Today is Tuesday. Can you go ahead and touch that Tuesday for us? Go ahead and touch that Tuesday for us. Excellent. So today is Tuesday. That's our day of the week. All of these days right here are our day of the week. Our month is called July. And then this is our date today. So who knows what number this is? So it has a big purple star on it. That's our date. And this is a number that you probably know. I bet you know this number. Is our number 7? Yes, today is the 7th day of July. So it is July 7th. And then our year is 2020. Excellent. So let's go ahead and touch that green arrow one more time. So yeah, you should see, we need to put our Tuesday and our 7th day back where it needs to go. So let's touch and drag our Tuesday where it needs to go in our day of the week. And then let's do the same with our number 7. So I'm going to bring our 7th day of back where it needs to go in our Tuesday row, right? Excellent. And then let's touch our arrow one more time. So this is our month of July, and I really like our calendar because it has little pictures or icons for special days. And another thing I like about it is that it doesn't just do days or holidays that are celebrated primarily in the United States where you might be living. I live in the United States. You might probably live in the United States, but we might get viewers that live outside of the United States in other countries. And I like this calendar because it shows some pictures and celebrates dates that might be celebrated in other countries. For example, on Wednesday, July 1st, was Canada Day. And Canada is a country that is right above, it's straight north of the United States. So if you ever looked at a map, maps are so good to look at. I highly suggest looking at maps. I love looking at maps. If you've ever looked at a map of the United States, there's a country right above the United States, and that is Canada. And so they celebrated Canada Day. And I should have done my research because I did not research a couple of days in our month of July. So I'm not really sure why they celebrate Canada Day, but if you tune in next week, I will make sure to know why what Canada Day is and what they celebrate. I think it might be like our 4th of July, which is going to be the next holiday, but don't hold me to that. Tune in next week and I will know better. I will do better. So let's talk about the next holiday that we see that I bet if you lived in the United States, you definitely, if maybe not celebrated, you probably celebrated this and you heard celebrations of it. Absolutely. So on Saturday, July 4th, is the USA's Independence Day, or what we call 4th of July. And so how many of you shot off fireworks? Did anybody shoot off fireworks on the 4th of July or even the days leading up to the 4th of July? Yeah, I see that our friend Daniel raised his hand. It can be, shooting off fireworks can be fun. It can be dangerous. You gotta be careful and listen to your grown-ups and make sure you're doing everything safely. But they're so pretty, aren't they? I love fireworks. And so I definitely heard them all night long at my house. And so, that is Independence Day is where we became our own country. We used to be the United States, or there were some states that used to be part of the country of England. And we decided we wanted to be our own country. So that is the day that we officially became our own country of the United States of America. So it was our Independence Day. And then our last day that is right down here on the 31st. And it looks like we have like a little sheep with a bow on it. And it is called Eid al-Adha. And I was so bad and I did not research my days. I did not look ahead at my calendar for July before I did today because we didn't have it last week and we didn't have a little lab on Saturday because of the 4th of July, and I did not do my research. So again, I will make sure I look up what this day is for next week because I am not quite sure. And I want to make sure I'm giving you all the correct information that we have on our calendars. So tune in next week or Saturday, and I will make sure I have all that right information for our days. So our month of July is pretty sparse. It doesn't have a ton of holidays or festival days, but what about birthdays? Does anybody have a birthday? I know I have a birthday, and I know you have a birthday, but does anybody have a birthday in our month of July? Does anybody have a birthday in our month of July? Oh yeah, there's a lot of people with birthdays, right? And a lot of people with birthdays in July. I'm not seeing any friends that have a birthday in July, but I have somebody special in my life that has a birthday on July 17th, and that is my daughter. Her birthday was July 17th. So I guess her first birthday is going to be on July 17th. So I'm going to put a little piece of cake on July 17th for my daughter's birthday. But yeah, if you have a birthday, let me know in the chat. Perfect. Okay, doesn't look like it. So we are going to move on. I am going to stop sharing my screen. There we go. Okay, so like I said, this month we are talking about experiments, and we kind of talked about like what an experiment was, right? It's where you wonder about something, you want to know what will happen if I do this, or what will happen if this happens. It's kind of asking a question and then wanting to know what the answer is a lot of times, but kind of in a sometimes a little bit more physical way. We're going to be doing some physical experiments. So we are going to be today we are going to be doing experiments, like I said before, with magnets. And so, like I said, you probably have some magnets on your refrigerator. So this actually works perfectly, because if you're at home, you can maybe do some of your experiments with me, or you can do some of your own experiments at home after Little Slab today. So magnets are little pieces of the substance that attract metal, especially metal called iron. So they will kind of stick to things, or have things stick to them more, like things will come and stick to them. And like I said, I have this little piece of it, and we can see how this sticks it, where most of the time, like for example, I have we'll say this lid I have some Play-Doh with me, right? I have this Play-Doh lid. Does this stick to it? No, it just fell right down. It's just falling right down. So most of the times we think like something has to stick to something if it's sticky, like glue or tape. But this isn't glue and this isn't tape, and it itself isn't sticky. I can touch it and I don't have any like stickiness on my fingers, but it kind of like attracts. It's what's called attracting things. So, and it like attracts a lot of times different types of metals, not all metals, but a lot of times different metals. So we're going to be doing some experiments with that. But I want to also read a story to help us kind of learn more about what a magnet is and how they work. So let's do that. I'm going to share my screen with you one more time. And so you should, I hope, can see like on my book, we're on Epic Books, and I have a book called Discover Magnets by Julia Vogel, illustrated by Jane Yamada. And so we are going to kind of learn a little bit about how magnets work. So a mysterious force. You can't see it and you can't hear it, but it has a power to push and pull. It's inside Earth, and everywhere around your home. What is this mysterious force? It's the power of magnets. So magnets are used by like a force, which is kind of like an invisible, we'll say like kind of like an invisible pressure that kind of blows through the air. It's kind of a hard thing, but it's easier to like know about whenever you see it, right? So the force of a magnet holds these little screws tight. So this, it kind of looks like my magnet, right? The magnet on the picture. And it can hold all these little screws on it by an invisible force. And will it stick? You know that magnets stick to a fridge. We talked about that, right? There are magnets probably on your fridge. But why? Why do magnets stick on your fridge? The door has a thin color coating, but underneath there's metal. So a lot of times nails have a lot of iron. Would they stick to a magnet? What do you think? We kind of talked about that. Yeah. Do iron nails stick to a magnet? I bet they do. So magnets attract certain kinds of metals. Most often, magnets stick to iron. So yeah, those iron nails would stick to a magnet. They can also pull on other magnets. So we can see here, these thumbtacks and needles would stick to a magnet, and a piece of string, what do you think? Would a piece of string stick to a magnet? Is it made out of metal? No, it wouldn't. Pennies don't scoot to a magnet, and neither does gold. Paper and pencils stay put too. These things are not made of iron, and so they are not magnetic. I wish I had a penny with me. I would kind of show you how a penny doesn't stick to a magnet. And so coins are the wrong type of metal to be sticking to magnets, which is probably good, right? Because you wouldn't want your coins, because what if somebody had like magnets on their fingers and then they would attract all these metal coins maybe out of something, and they might not be doing it for good reasons. So our coins are definitely not magnetic. And so things made out of paper, plastic, wood would not stick to magnets. So we're going to kind of be experimenting with that today. So magnets come in different shapes and sizes. Which one can pick up the most stuff? It may not be the biggest one. Even small magnets can grab things they're not touching. Hold a refrigerator magnet above a paper clip. You can make a paper clip jump. We're going to be kind of doing an experiment like that. So a big magnet like this one over here are used at junkyards. And then this little magnet holds all those paper clips. But there you could have a really big magnet and a really small magnet. And the really small magnet can be more magnetic than that really big one. So it doesn't matter the size, it matters how much attractive force it has. And even really, really small ones can be super magnetic, which can mean that sometimes you have to be careful around magnets because they can be really attractive and they could hurt, like pinch you or something like that. So you got to be careful with magnets. But what happens if you move a paper clip across the room? The trick doesn't work. Around each magnet is an invisible space. This is called a magnetic field, and magnets only work within that magnetic field. So you can kind of see here in this picture, there's these are the magnetic fields around, and one side says an N and one side says an S. And that is because they're called poles. And like I have a little, it's kind of hard to see. Oh, there we go. It might be better this way or this way. Trying to make sure it looks like an N and an S for you guys. But yeah, this one has an N on one side and an S on the other. And basically those are called poles. So there's a North Pole and a South Pole. What else has a North Pole and a South Pole? Does the Earth have a North Pole and a South Pole? It does, because the Earth kind of is like a big magnet, a little bit. It's like a really, if we had to think about magnets, it's a big magnet. It has a North Pole and a South Pole, and we have a magnetic field around us. And so we could see that this little guy is attracted, but I can only have it a little bit far away and it still drops. It has to be really, really close for it to be attracted to it, right? And that's because this doesn't have a very good magnetic field. But this one, look at that. It could be really far away. Oh, not that far. Let's try one more time. Oh, it could be pretty far away, a lot further than this guy, and it still attracts. So this one has a greater magnetic field. It can attract things further away from it. So like I said, the planet magnet, what's the biggest magnet on our Earth? It's Earth itself. It is one big giant magnet. So yeah. So I'm actually going to end this here because I want to make sure we have time to do some of our experiments. So I'm going to stop sharing because I want to make sure that we have time to do that. So like I said, we have things that have, magnets have kind of poles. And so there's a North Pole or a South Pole. And a lot of times, like we said, things that are metal can attract, that have metal on it. So this little guy, this little thing, it's made of plastic, but it has like a little ring inside that has maybe some irony metal in it, right? But let's look at this. So a lot of times this is also a magnet, right? But magnets, they can attract to each other, but they have to be certain sides. So like this side has a north side and a south side, a North Pole and a South Pole. So does this little magnet. So this obviously is attractive, right? But watch this. I'm trying to push this side of the magnet onto this side of the red magnet, and they are not sticking. It's actually pushing away from each other. So if you have some magnets, you should try this out because you can physically feel how they're pushing away from each other. They they're of the same pole. So this would be the north pole of the magnet, and this is the north pole of the magnet, and they don't want to stick. But if I turn it around, that is because opposites attract. You can kind of see it. I have another little magnet that has an S and an N on it. And so if I put our ends together, they don't want to stick. But if I put our S and our N together, look at that. It sticks. And it's the same on the other side. I try and put our south ones together, our S's together, they don't want to. They want to repel each other. But if I put our N's together, look at that. So it really kind of depends on the magnet itself. So let's do some experiments, right? I have this really cool, it's called a magnet wand. And so I'll show you how it is a big magnet, right? So it can attract things. And just like it has these are the opposite sides. And then if I try and turn it over, this doesn't want to. Oh, it twists around. So let's try and do an experiment and let's see what a magnet will attract and what it won't. And so this is what I want you to do. I'm going to give you an option. I'm going to show you something. Like, for example, I have this piece of foam right here, and I want you to share either with your family or in the chat. Do you think this will attract? Do you think this will stick? How about we do this? We'll say stick or not stick. Do you think this will stick, or do you think this won't stick? Let's see. Let's see if this will stick. I'm going to press it right up. And if it falls, then it's not sticking and it's not magnetic. And if it stays, then it sticks and it is magnetic. Let's see if this piece of foam is or is not magnetic. It's not. It fell. It didn't stick on there. So that piece of foam is not magnetic. Let's try something else. I have this it's like a little washer. And it's metal and smooth. So what do you think? Do you think this is magnetic? Will it stick or will it not stick? Let's find out. You share with your family or with the people that you're with if you think this will stick or not stick. Let's find out. I'm gonna put it, and it's stuck. It's magnetic because it's made of metal, right? It is, it's made of metal. Let's do a few more. I said I had some Play-Doh, right? I have some Play-Doh. So what do you think? This one's kind of tricky, right? What do you think? Will this stick or not stick? Is it magnetic or not magnetic? Let's find out. It is not magnetic. Play-Doh is not magnetic. Let's try one more. And how about this little guy? It's kind of similar. Do we think will it stick or not stick? It stuck. It's magnetic. It was just like our blue one. I wanted to try and trick you. But yep, these little guys have little metal rings in them. So they are magnetic. So yeah, so if you have a magnet around your house, maybe a kitchen magnet, you could go around and testing and experimenting to see what around your house is also magnetic and what's not. And then I also have a fun trick for you to do as well. So this is a paper clip. It's just a metal paper clip. It has a piece of string onto it. So let's do one more experiment of, is it magnetic or not magnetic? Let's see. What do you think? Will it stick or not stick? It's stuck, right? So our paper clip is magnetic. So this I have an experiment to show you to kind of show you how that magnetic field works, right? That was kind of the area in which things will attract each other. So what I'm going to do is let's see if I can zoom this down. I'm going to hold on to the end of this is my paper clip. I'm going to hold on to the other end, and then I'm going to bring this back up here. And so, attracting all sorts of things. Okay, so I'm holding down one end, and you can see how I have my paper clip attracted, or it's touching. What if I lift up our wand just a little bit? What is it doing? It's still holding up. So that just really shows you how that magnetic field works, where things don't have to be touching to still attract. And so you can kind of see the range. So I can, let's see how far higher up I can, oh, there it goes. So about an inch, right? It was about an inch, maybe inch and a half before our paper clip fell. And you can do this too. I bet if you have something metal that you can tie a string to, you can make that thing fly. And you can try and do an experiment to see how strong your magnet is, because this kind of shows you. So that's about an inch. Let's see with my little metal or my little circle. Let's see if the attraction, this one doesn't attract as nearly as far, right? It almost immediately, it has to be pretty close before, and maybe, let's see if this one has any. Oh, nope, this doesn't have a very strong attraction either. So our wand has the largest attraction. So if you have multiple magnets, test them out. Maybe you can see the range of their magnetic field to see how far away things can go before it falls down. So there's a lot of experiments that you can do at home today or this week. So that's what I encourage you to do. Do some experiments. If you have some magnets, some kitchen magnets around the house, find out, go around your house with maybe your grown-up or a sibling, and maybe be very scientific about it, and maybe write down what you're trying to attract. Like maybe it's a doll or a pencil or a hammer or some scissors, things like that, and write down if it's magnetic or not magnetic, and make it very scientific. And then you can also test the range of your magnet as well on different things. So I hope you have so much fun doing some experiments this week at home. And maybe think about it. What other experiments can you do around the house? We're going to be doing some more next week. Next week, we're going to be working with water, and we're going to be experimenting to see what floats and what doesn't float. So hopefully you can join us again next Tuesday to see what floats and what doesn't. Well, we are just about over with Little's Lab. I hope you had a good time, and we will see you next time. Have a good day. Bye.